Sorry. So, sorry. I didn't put my scissors on here. This is the front. Let me get my thing. You should cut on this dotted line right here to create your two tabs. First tab, independent. The two outcomes, the first outcome does not affect the second. Will you bring that over here? Will you bring that over here? Yeah. All right, so what I need you to try to determine, the first one is just different scenarios, and then we're gonna determine if right here, if the event is independent. So if you roll a cube and toss a coin, does rolling a cube affect your toss of the coin? No. So since it does not affect it, this is an example of an independent. You can put an X or you can put a check, but that's an example of an independent event. What if you spin two spinners? I know. If you spin it 2 times, does the first spin affect the second spin? No.
Do you reset the spinner to its original position or set
There's, okay, it's one spinner, but we're spinning it twice. Does that make sense? Like you have a spinner, it could be divided into different categories, but like you have a spinner, right? If I spin it once, does it affect when I spin it the second time? Does my first spin affect the second spin? Like this is an example of a spinner. What's the odds of getting, let's say I have numbers 1, 2, 3, and 4. What's the odds of getting a 1 on the spin the first time?
1/4.
1/4. Okay. So then when I do it again, what's the odds of getting a 1? Don't eat in this classroom. Will you put that away, please? So this is also independent. If it does not affect the outcome to the next, then it is an independent event. What about, okay, you have a bag, and we're going to do that in our example down here. Because they're trying to say you had a bag full of different pieces of candy. Let's just say we had jelly beans. If I choose a red jelly bean out of the bag and eat it, and then try to choose another red, does my second pull is it affected by the first?
Yes.
Yes. Okay, so it's because this is affected, this is not independent. Okay. What if I choose a red jelly bean from the bag, replace it, meaning put it back in the bag, and choose another red jelly bean?
It's independent.
Yeah, this is still independent. What we're first going to just ask you to determine is if it's independent or dependent. All right, so whenever you're finding the probability of 2 events occurring, you are going to have to multiply the probability of each event. So this is saying the probability of A and B. Notice that they separated of the probability of A, then times that by the probability of B. B is not affected by A. And that's what we're going to practice on the first set of examples. In this scenario here that we want you to try, it says, the first one says you roll a number cube and toss a coin. So we do a probability of heads. I'm just going to put an H times the probability of rolling a 1. What's the probability that you flip the coin and it's heads? 1/2. There we go. What's the probability that you roll a 1? Yeah, 1/6. So we're doing 1/2 times 1/6, which would give me 1 out of 12. You just multiply the top numbers together and the bottom numbers together. All right, now we're doing probability of tails. So I'm just put a T, and the probability of rolling an even. I'm gonna put an E there. What's the probability of tails?
1/2.
Yes. What's the probability of rolling an even? 3 out of 6. What does 3 out of 6 reduce to? 1/2. So the probability of tails and even is 1/4. All right, so we're gonna choose candy from a jar, replace it, and then choose another. You have to replace it for it to be independent. So we want a probability of 2 reds. Okay, so we're doing the probability of the first red times the probability of the second red. If you look, they're trying to indicate, I'm just gonna get my color, my pencil. Are the reds that we have, and B are our blue candies. Oops, that's supposed to be blue. How many do we have in the jar?
12.
12. Okay, so there's 12 total. You need that total to indicate the probability of each event. All right, so probability of red the first time. 8/12, yeah, reduces to, yeah, 2/3. Sorry. All right, so let's say you take out a red, but then you put it back in. So the next probability is still gonna also be 2/3. So the probability that you do red twice is gonna be what?
4/9.
Yep, 4/9. You just multiplying 2 times 2 and 3 times 3. All right, now we want to do probability of red and blue. So red times the probability of blue. We already know our probability of red is 2/3.
Yeah.
What's the probability of blue?
1/3.
We have 2 out of 12. I'm sorry, 4 out of 12 reduces, yes, to 1/3. All right, multiply those together. Yep, 2/9. All right, so this is examples of independent events. We're going to start doing compound events. So that's going to be 2 or more event at once. And then whenever we have 2 or more, we're going to multiply the probability of each. All right, so for dependent, they've already underlined here, happens, the dependent events happen when one event does affect the outcome of the other. So the second event is affected by the first. So if I choose a red jelly bean from a bag, eat it, and then choose another red, is that dependent or independent? Yeah, so this is dependent. Once I eat that red jelly bean, I don't have the same total outcomes or possibilities. All right, so it's going to affect the second one. What if I choose a red jelly bean from a bag, replace it, and choose another red?
That's independent.
That's independent. Yeah, this is independent. And then you choose a student to leave for lunch, then choose a second student from those remaining. Yep, this is dependent. All right, so the process is still the same. When you find the probability of 2 events occurring, you're going to multiply the probability of each event. Okay. The thing is, the first event is not affected, but probability of B following A depends on A. So we're gonna look at this same scenario. Okay, so the effect on the second event is going to change. Yes, go ahead. All right, so what's the probability of red? We did this one already. Okay, 2/3. Now, remember, if I take a red out, the next probability each event is changing because our total is not the same.
7-11.
Okay, the first we're starting with total of 12, but for the second event, our total is now, once I take it out, is 11. But how many reds do we have remaining?
7.
Yeah, out of the 11. So now we're just multiplying across. Top times top, 2 times 7 is 14. 3 times 11 is 33. So you're going to have to subtract on dependent events. All right, so now we're doing red and blue. Red is going to be 2/3. But what's our probability of blue? The second one. How many blues do we have?
4-11.
Yeah, it's 4 out of 11. Because once we take one out, our total goes down by 1. All right, now we're just multiplying straight across. So what's our probability of red and blue? Yeah, 8/33, yes. All right, new scenario. We're now pulling from a drawer of socks. It tells us here that we have 4 white socks, 3 blue, 6 red. So we need to know our total.
13.
13, yeah. All right, so we want you to try to calculate the probability of red, then our probability of blue. It says that once you select one, you put it on your foot, so you don't put it back in the drawer. Then you have to select another one. Once you try this one, and then we're gonna just practice understanding independent or dependent, and then some actual calculations. Okay, so hopefully you did. Red was 6 out of 13, and blue was 3 out of 12. Okay, when you multiply, you get 18 out of 156. But this reduces to 3 out of 26. Make sure you reduce it. You should just multiply top numbers and bottom numbers and then reduce it. Okay, so this is the first part of what I'm checking for today. All right, so you're gonna have to determine, you're gonna need 2 different colors for this activity. You get 2 different highlighters. If you need to borrow colors, I can give you some. You can check with your group members on your choices. The first part I just need you to be able to identify is it independent versus dependent. Okay, so just you need to indicate your key, meaning what you're going to represent as what color is going to represent independent. I'm just going to do 2 different color highlighters. So like yellow will be my independent and blue can be my dependent. You need to have 2 different colors. No, 2 different colors. Okay, so all you're doing, because you're picking, you determine your color, Whatever, based on the scenario, you're gonna read each event, determine if it's independent, that's yellow for me, and dependent. Okay, so all right, so on this first, I'm just gonna go over the first couple with you, just make sure you're on the right track. All right, it says Josiah, has a bag of assorted jelly beans. He pulls one out, puts it back, and then pulls another. Is this independent or dependent? Yeah, this would be independent. Because he replaces it, the second event is not affected. So we would just shade or highlight the circle, the color that you have that's representing independent. Lena flips a coin and rolls a die. Would that be independent or dependent? Yep. Here we have at a grocery store, Grace is picking out a frozen pizza. Meanwhile, at another store across town, Ellie's picking out a frozen pizza. Yeah, independent. They're at two different stores. Okay. All right, here we have Kira randomly draws a card from a deck without putting it back, draws another card. This is dependent. So now this is my color what I pick for dependent. Okay, does everyone understand what we're doing here? Okay, so this, you're going to put it in the tray when you're done, and then you can get your laptop to start on your practice. The practice is going to be in quizzes. Yeah. You can check with each other.